So in this lecture, we want to solve the same equation, but use the three different possible answers. So in question 1, we're going to be solving 2 sine theta minus 1 equals 0 on this interval. In question 2, we're going to solve the same equation, but find the general formula. And in question 3, again, we're solving the same equation, but this time we're finding 6 possible solutions. So let's go back to question 1. When you're asked to solve on an interval, the first thing you want to do is isolate the ratio. So here we're going to isolate sine theta. I'll let you do that. In the part B, we want to determine which quadrant or quadrants we're going to be in. Sometimes we might be on an X or Y axis. Let's write that in. Now, the thing to remember is that all of our ratios and their reciprocals are positive in 2 quadrants and negative in 2 quadrants. We see here that sine theta is positive. Which quadrants are my answer going to be in? The easiest way to determine that is to use our CAST rule. We remember that all of the functions are positive in quadrant 1, and sine is positive in quadrant 2. Why don't we go ahead and draw triangles in quadrants 1 and 2? Fill in the sides as well. Next, we want to find the reference angle. I hope you recognize these triangles where 1 is across on one side and 2 is the hypotenuse. We know this is our 1, 2, root 3 triangle. And so our reference angle in each of these is 30 degrees. Finally, we want to find theta for each quadrant. Remember, in quadrant 1, theta is the same as the reference angle. In quadrant 2, starting on that same initial side, we see that our reference angle is 30 degrees. So theta is 30 degrees less than 180 or 150 degrees. Now, we were given our interval in radians, so we should answer in radians. We've found all of the answers from 0 to 2 pi radians. There is no solution where sine is positive in quadrant 3 or quadrant 4. Now, the next question asks us to find the general formula. The first thing we want to do is solve for theta on the interval 0 to 2 pi radians. We did that already. That's what we did here. We found that in quadrant 1, theta was 30 degrees or pi by 6 radians. And in quadrant 2, theta was 150 degrees or 5 pi by 6 radians. So for sine and cosine and their reciprocals, we're going to apply the periodic formula for each value of theta. We know that sine repeats every 360 degrees. So in degrees or in radians, it repeats every 2 pi radians. We do that for both values of theta. Now, whether you use degrees or radians depends on how the question is asked. In this one, it didn't tell you to use radians or degrees, so it didn't matter which one we chose. But this is it. These are our general formula. What do we have to remember? That k is any integer. Now let me just remind you that it doesn't have to be k. We could have said n. So when you're answering questions in MATLAB, read the question carefully. Pay attention to what variable they want you to use. We should also note here in part C that if we're solving for tangent or its reciprocal, we're applying that periodic formula only in quadrant 1 or quadrant 2. There will only be one formula, not two. So now we have our general formula. Question 3. In question 3, we're asked to solve the same equation, but find 6 possible solutions. How do we do that? We use the general formula we just found. And once we use those, we can substitute any integer values for k. So let's write down our 2 formula here. We're asked to find 6 solutions, and you can see I've left space here for us to put in 6 possible values of k. I always think it's easiest to use the smallest numbers possible, so I generally let k equal -1 for both formulas, k equals 0 for both formulas, and k equals 1 for both formulas. So here I have theta equals 30 degrees plus 360 times -1. 30 degrees minus 360 degrees gives me an answer of -330 degrees. Why don't you find the other 5 values for theta? So here are 5 possible solutions, or sorry, 6 possible solutions. These are not the only solutions. Remember, k could equal any integer. If you decided you wanted k to equal 27, you could. Now you do have to be careful when you're answering in Pearson MyLab to pay attention to whether or not you're asked to solve in degrees or radians. I usually, like at least when I'm working with students, to first answer in degrees and then change the answers to radians. So why don't you go ahead and change each of these to radians? I expect, of course, you were able to do this without a calculator because that's how you would be doing it on your test and your exams.